Now we're gonna learn nucleophilic substitution reaction. So today we're gonna learn nucleophilic substitution reaction. So nucleophilic substitution reaction has various type of reaction. Like first is our SN1, second is our SN2, third is our SN1 dash, fourth is SN2 dash, fifth is SNI, sixth is SNNGP, seventh is SNAR, eighth is SNAE, ninth is SNEA, which is also is known as benzene mechanism. Right, so we're gonna understand today what is the nucleophilic substitution reaction. Suppose we have a alkyl halide RX which attacks on nucleophile Nu minus, and we have a solvent over here. Any solvent it could be. We're gonna laterally study each and everyone in detail. So we have a solvent. It reacts into form RNU plus X minus. Then it's replaced actually. If we take the example over here, we have CH3Cl which reacts with OH minus and which forms H2O and CH3OH and Cl minus. So this is also known as substrate. This is known as substrate to which nucleophiles attack. It is also known as nucleophile. It is known as nucleophile, and this is known as solvent. This is known as a leaving group, which is leaving. It is known as leaving group. And so what happens? This nucleophile replace another nucleophile. Okay. So if we see this nucleophile, this replace this nucleophile. It substitute this nucleophile. Okay, nucleophile is what? Which is philic towards nucleus. So nucleus is positive charge, which will attract towards nucleus. A negative charge will attract. So an electron dense compound or negative charge compound is known as nucleophile. So OH replace Cl minus. So this is known as nucleophilic substitution reaction. Now what are the factors which affect the nucleophilic substitution reaction? So we're going to look about the factors affecting SN reaction. So which factors affect the SN reaction? So first is substrate. How should a substrate look like? Substrate could be CH3Br. It could be 1 degree. It could be 2 degree. It could be CH3CH2Br. It could be also 1 degree. It could be 3 degree. Right, so this all these type of compound are possible. Okay, it could be like a CH2 double bond CHCl, which is also known as a vinyl. It could be allylic substrate, CH2 double bond CH2. This is known as allylic substrate. This could be a phenyl also. This is a phenyl. It could be benzyl also. This is known as CH2 benzyl. This could be a bridgehead carbon. That's type of bridgehead. Bridgehead also. And it could be a tertiary butyl also. So these are the examples which type of a substrate are possible. Right. Now these type of substrate are possible. But this type of substrate are possible. Now this was substrate. Now how does a leaving group look like? Leaving group. How could be a leaving group look like? So leaving group has a tendency like RL, which reacts with a nucleophile in solvent, forms RNU plus L minus. So this is known as a leaving group. This is known as a leaving group. So actually what are the leaving group? Weak bases. Weak bases are the good leaving group. This is actually a textbook definition weak bases are the good living. But how do I recommend? I recommend that which anion is from a strong acid. Let's L minus is from HL and HS is a strong acid, then it is a good living group. We're gonna not check every time the base. We're gonna check the acid, and that anion is a very good living group. Like A. If we write fluorine, chlorine, then bromine, then iodine, which is a living group ability, which is a good living group. So living group is iodine, bromine, then because HI is a good acid. And so now basic strength, base in F minus, Cl minus, its conjugate base must be weak, I minus. And we know that respective acid has directly proportional to the living group tendency. Respective group acid has a very good living group tendency. Now we have some more examples of our living group questions. First we have CH3, C double bond O, O minus, then CH3, S double bond O, O minus. So which is a good living group? We know this is a strong acid because it has a more acidic structure. It has more number of resonating structure. More number of resonating structures. Second, or we can say like we have a CH3, S double bond O, OH. Then we have CH3, C double bond O, OH. So it also has more resonating structure. So methyl sulfuric acid is more than acetic acid, acidic strength wise, right? Second, this fluorine, chlorine, bromine was the first. It was the second. Now we're going to look at third problem. We have CS3O minus. We have an acetate ion, C2C-O minus. So this is a very good acid because it has more number of, its anion has more number of resonating structure. Fourth, we have O minus and SH minus. In both the case we have same negative charge, but it is then O minus has a smaller ion and SH minus has larger ion. So the negative charge disperses over all the molecule. So it de-intensify the negative charge. It de-intensify the negative charge. So that's why it is a strong, it is a stable compound. So H2S is a good acid and SH minus is a good living group. Now other good living group are possible like CH3. This methyl group has S double bond O then O minus. It is a good living group. It is also known as OTS. Its name is para toluene sulfate, or it is also known as tosylate. OTS is also known as tosylate. Sixth group we have sixth comparison. We have phenyl sulfate, then carboxylate phenyl, CH3 double bond O negative. So sulfate has more tendency. We have seen the sulfate is also always a more acidic strength. Then its anion is a good living group because it has more number of resonating structure. Seventh we have CH3, S double bond O, O negative. It is known as methyl sulfonate or mesylate. It is also known as mesylate, right? Now we're gonna look some more examples. 8. We have CF3, S double bond O negative. This is known as trifluoro methyl sulfonate, or it is also known as triflate. 9th we have NO2, S double bond O. It is also known as nosylate. 10th we have brosylate, S double bond O minus, brosylate. Right. Now next 11th we have CH3 C double bond O, O minus, and comparison between CF3 C double bond O, O minus, which is a strong, which comes from a strong acid. Second one, so CF3 C double bond O minus has a good leaving group ability. 12th we have O H minus and H2O. H2O is a weak acid, and so H2O is coming from H3O plus, and it is coming from H2O. So which is a good acid? Good acid. H3O is a good acid, so it is a good leaving group. 13th we have RO minus is greater than ROH, right? Same reason. 14th we have PHO minus is greater than PHOH, less than PHOH. Sorry. 15th we have RC double bond O, O negative, greater than RC double bond O, OH. This is our 15th. So this was all about our leaving groups. Now we're going to talk about our solvent. We're going to talk about our solvent or our medium. So in order to talk about the solvent or medium, first of all we have non-polar solvent. Non-polar, mu dipole moment is 0. B, we have a polar solvent. A polar solvent dipole moment is not 0. So non-planar, non-polar, mu equals to 0, like CCl4. These are all are non-polar compound. Then mu is 0. Mu we're gonna learn in chemical bonding. You're gonna see my course coming on chemical bonding also. Just wait, and you're gonna learn over here. So polar has polar protic and polar aprotic. Polar also has two categories. We have non-polar and polar. Non-polar is simple dipole moment 0, but polar has two category. One is polar protic and second is polar aprotic. So what is polar protic? The polar compound which can donate H plus. Proton means H plus. Proton means H plus. So polar compound like HO, HN, HF type of compound which have these type of bond, so it can easily donate H plus, like H2O, ROH, like PHOH. These are polar compound and it can also donate H plus because it has OH bond, right? Like an RC double bond O, OH, RC double bond O, NHR. So it has NH bond, so it can also donate H plus. So what happens? What does happen when we use the polar protic solvent? Polar aprotic. We're going to talk about polar aprotic solvent. What does happen? Okay. So when we have a positive charge and we have a negative charge. So positive charge is surrounded by H2O. It can surrounded by delta positive, and delta negative. Delta negative. It is also surrounded by H, delta negative, delta positive, delta positive. It is also surrounded by O negative, H, delta positive and delta positive. So a positive charge, sorry, wait. This is a negative charge, right? A negative charge is surrounded by positive polar of a dipole, but a positive charge is surrounded by negative pole of dipole. So what happens? Delta positive, delta positive, delta negative, delta positive, delta positive, delta negative, delta positive, delta positive, and delta negative. So what happens? A negative charge is surrounded by a positive charge. A positive charge is surrounded by a negative terminal. So a polar aprotic solvent, solvent both cation and anion. So polar protic solvent solvates both cation as well as anion. It solvent both cation as well as anion. So this is the specialty. Now we're gonna look about our next term. So we're gonna look polar aprotic. What does a polar aprotic does? Polar aprotic. What does a polar aprotic does? We have some examples of polar aprotic compound. CH3 C double bond O, CH3. It is also known as, here it is sulfur, DMSO, dimethyl sulfur oxide, dimethyl sulfur oxide. And we have HC double bond O and CH3 and CH3. We have DMF, dimethyl formamide. Next we have CH3, C double bond O N. Then we have CH3 and CH3. It is also known as dimethyl acetamide, which is known as DMA. We have one more example of polar protein, which is known as HMPA, P double bond O phosphorus and CH3, CH3 and CH3, CH3 and CH3 and CH3. It is hexamethylene phosphamide, which is known as HMPA, hexamethylene phosphamide, HMPA. Some more example like crown ether. Crown ether. This is also known as it is also known as 9 crown 3. It has 9, 1, 2, 3, 4, 5, 6, 7, and 9. Out of 3 we have oxygen. So it is also known as crown ether, 9 crown 3. So what is special? We have seen that the polar protein dissolves both solvent, both cation and anion. What does about polar aprotic? Polar aprotic, we take example dimethyl sulfur oxide. So it has delta negative positive charge, and here we have delta negative. On oxygen we have delta negative. So does the delta positive charge can surround a negative charge? No, because we have two bulky methyl groups attached over here. So only this tail can surround. This tail can surround. So this tail can only surround positive charge. Like this. Sulfur CH3. Delta negative, delta negative, delta negative, and delta negative. So that's how a negative charge is being positive. It could always solvent positive charge. So it doesn't solve it. So what is important? Polar aprotic solvent, solvate cation, but not the anion. Not, it can solvent cation but not anion. Like so. Now we have seen that what is the effect of nucleophilic substitution reaction, what is the solvent and what are the solute, and what are the different type of solvents.